Welcome, tech enthusiasts, to another exciting episode of Ansible at Techhandy. Today, we're embarking on a journey through Ansible, the robust open-source automation tool. Whether you're a seasoned IT professional or just stepping into the world of automation, this video is your gateway to mastering Ansible. So, buckle up as we explore the fundamentals before diving into advanced topics. Let's get started. The behavior of an Ansible installation can be customized by modifying settings in the Ansible configuration file. Ansible chooses its configuration file from one of several possible locations on the control node. The Ansible package provides a base configuration file located at listed path. This file is used if no other configuration file is found. Ansible looks for a ansible.config file in the user's home directory. If it exists, this file configurations is used instead of the base configuration file. If an ansible.config file exists in the directory in which the Ansible command is executed, it is used instead of the global file or the user's personal file. This allows administrators to create a directory structure where different environments or projects are stored in separate directories, with each directory containing a configuration file tailored with a unique set of settings. You can use different configuration files by placing them in different directories and then executing Ansible commands from the appropriate directory, but this method can be restrictive and hard to manage as the number of configuration files grows. A more flexible option is to define the location of the configuration file with the Ansible_config environment variable. When this variable is defined, Ansible uses the configuration file that the variable specifies instead of any of the previously mentioned configuration files. Because of the multitude of locations in which Ansible configuration files can be placed, it can be confusing which configuration file is being used by Ansible. You can run the Ansible version command to clearly identify which version of Ansible is installed, and which configuration file is being used. The Ansible configuration file consists of several sections, with each section containing settings defined as key value pairs. Section titles are enclosed in square brackets. For basic operation, use the following two sections. Defaults to set defaults for Ansible operation, and privilege escalation configures how Ansible performs privilege escalation on managed hosts. In the defaults section, the inventory directive can point directly to a static inventory file, or to a directory containing multiple static inventory files and dynamic inventory scripts. Ansible connects to managed hosts using the SSH protocol. The most important parameters that control how Ansible connects to the managed hosts are also set in the defaults section. Ansible attempts to connect to the managed host using the same username as the local user running the Ansible commands. To specify a different remote user, set the remote user parameter to that username. For security and auditing reasons, Ansible might need to connect to remote hosts as an unprivileged user before escalating privileges to get administrative access as root. This can be set up in the privilege_escalation section of the Ansible configuration. To enable privilege escalation by default, set the directive become in the configuration file. Even if this is set by default, there are various ways to override it when running adho commands or Ansible playbooks. In current showing Ansible config file, Ansible assumes that I can connect to the managed hosts as admin using SSH key-based authentication, and that admin can use sudo to run commands as root without entering a password. An inventory defines a collection of hosts that Ansible will manage. These hosts can also be assigned to groups, which can be managed collectively. Groups can contain child groups, and hosts can also be members of multiple groups. The inventory can also set variables that apply to the hosts and groups that it defines. Host inventories can be defined in two different ways. A static host inventory can be defined by a text file, or a dynamic host inventory can be generated by a script or other program as needed, using external information providers. In addition, you can also specify ranges in the host names or IP addresses to simplify Ansible host inventories. You can specify either numeric or alphabetic ranges. Ranges match all values from start to end, inclusively. Listed example matches all hosts named server01.techhandy.ca through server20.techhandy.ca. You can use the Ansible command in various ways to verify a machine's presence in the inventory or to list all hosts in specific group. The mentioned Ansible path file is considered the system's default static inventory file. Normal practice is not to use that file but to define a different location for inventory files in your Ansible configuration file. The Ansible and Ansible Playbook commands that you use to run Ansible ad hoc commands and playbooks can also specify the location of an inventory file on the command line. Imagine having the power to perform quick tasks without the need for elaborate playbooks. That's where ad hoc commands shine. An ad hoc command in Ansible refers to a one-time command that you run against your managed hosts without the need to create a playbook. It allows you to perform quick tasks or gather information on remote systems directly from the command line. Ad hoc commands are particularly useful for tasks that don't require a complex script or playbook. You can use ad hoc commands in various scenarios, such as, to validate the uptime of 1 to 200 remote servers or to get the disk space of remote hosts, ping and validate if the server is alive and responds, shut down multiple remote hosts at a single command and much more. The host pattern argument is used to specify the managed hosts on which the ad hoc command should be run. It could be a specific managed host or host group in the inventory. The M option takes as an argument the name of the module that Ansible should run on the targeted hosts. Later videos we will see how to harness the flexibility of ad hoc commands for tasks like system checks, updates, and more. Now that you're familiar with the basics, let's delve into tasks, plays and playbooks, the Ansible's automation scripts. Let's start with task. A task is the smallest unit of action you can automate using an Ansible playbook. A task is the application of a module to perform a specific unit of work. A play is a sequence of tasks to be applied, in order, to one or more hosts selected from your inventory. A playbook is a text file containing a list of one or more plays to run in a specific order. Plays allow you to change a lengthy, complex set of manual administrative tasks into an easily repeatable routine with predictable and successful outcomes. In a playbook, you can save the sequence of tasks in a play into a human-readable and immediately runnable form. A playbook is a text file written in YAML format, and is normally saved with the extension YAML. The playbook uses indentation with space characters to indicate the structure of its data. YAML does not place strict requirements on how many spaces are used for the indentation, but there are two basic rules. First, same indentation, and second, items that are children of another item must be indented more than their parents. A playbook begins with a line consisting of 3 dashes as a start of document marker. An item in a YAML list starts with a single dash followed by a space. The Ansible Playbook command is used to run playbooks. The command is executed on the control node and the name of the playbook to be run is passed as an argument. The default output provided by the Ansible Playbook command does not provide detailed task execution information. The Ansible Playbook verbosity command provides additional information, with up to 4 total levels. Prior to executing a playbook, it is good practice to perform a verification to ensure that the syntax of its contents is correct. The Ansible Playbook command offers a syntax check option that you can use to verify the syntax of a playbook. The display example shows the successful syntax verification of a playbook. When syntax verification fails, a syntax error is reported. The output also includes the approximate location of the syntax issue in the playbook. You can use the C option to perform a dry run of the playbook execution. This causes Ansible to report what changes would have occurred if the playbook were executed, but does not make any actual changes to managed hosts. Variables add a layer of flexibility to your automation. Variables are a way to pass or store values. Like any other systems, Ansible also support variables. Variables provide a convenient way to manage dynamic values for a given environment in your Ansible project. Examples of values that variables might contain include users to create, packages to install, services to restart, files to remove, archives to retrieve from the internet, and much more. Variable names must start with letter, and they can only contain letters, numbers, and underscores. There are multiple variable types to use. It can be inventory variables, play variables, system variables, or extra variables type. Let's define each of the variable types with examples. Inventory variables are defined in the inventory file, allowing you to set specific variables for different hosts or groups of hosts. In this example, the HTTP port variable is specific to the web servers group, defined under web_servers, vars. The DB port variable is specific to the DB servers group, defined under DB_servers, vars. Play variables are defined within a play in a playbook. They are specific to that play and can be used for tasks within that play. In this example, the global_var is a global variable defined at the play level. The play_var is a play-specific variable defined only for the second task within the play. System variables are predefined variables provided by Ansible that contain information about the system, such as facts gathered during playbook execution. In this example, Ansible_distribution is a system variable that contains information about the Linux distribution on the target system. Extra variables are passed to Ansible at runtime using the E or extravars option. These variables are not defined in the playbook but are provided when running the Ansible Playbook command. In Ansible, facts refer to pieces of information collected from the target system during the playbook execution. Facts provide details about the system's configuration, hardware, network, and more. Ansible gathers these facts by default at the beginning of playbook runs. Let's see how to manage facts in an Ansible playbook with some examples. You can use the debug module to display facts gathered during playbook execution. In this example, Ansible_facts contains a dictionary with all the facts collected during the playbook run. When you run this playbook, you'll see a detailed output of system information. You can reference individual facts within tasks. For example, let's say you want to use the operating system fact to conditionally execute a task. In this example, the first task displays the operating system information, and the second task uses the when condition to execute a task specific to Ubuntu. You can also define your own custom facts and use them in your playbook. In this example, the set_fact module is used to define a custom fact, my_custom_fact. This fact can then be referenced in subsequent tasks. If you want to control when facts are gathered or disable fact gathering altogether, you can use the gather_facts parameter in your playbook. In this example, fact gathering is disabled, gather_facts, false, but you can still reference previously gathered facts. By effectively managing facts in your playbook, you can make informed decisions and perform specific tasks based on the characteristics of the target systems. In Ansible, handlers are special tasks that are only executed if a task notifies them. Handlers are typically used to perform actions such as restarting a service or reloading a configuration file when changes are made during the playbook run. Handlers are defined separately from tasks, and they are only executed if they are notified by a task. Let's see examples that explain how to implement handlers in Ansible playbooks. Handlers are defined in the Handlers section at the same level as the Tasks section in your playbook. In this example, two tasks are defined: ensure Nginx is installed and ensure Nginx configuration is updated. The notify keyword in each task indicates that the associated handler, restart Nginx, should be triggered if the task makes changes. If no tasks notify a handler, it won't be executed. When you run the playbook, Ansible will track which tasks notify handlers. After completing all tasks, Ansible will then execute the notified handlers. This ensures that services are restarted or configurations are reloaded only when necessary. Handlers are executed only once at the end of the playbook run, even if multiple tasks notify the same handler. Also, handlers are a great way to consolidate service restarts or other actions triggered by multiple tasks, avoiding unnecessary restarts if no changes occurred. By using handlers, you can implement a more controlled and efficient playbook execution, ensuring that only the necessary actions are taken when changes are made during the playbook run. We are moving to last topic of this video. Task control in Ansible playbooks involves using directives like when, changed_when, and failed_when to control the execution and behavior of individual tasks. These directives allow you to add conditional logic to tasks, making your playbook more flexible and responsive to different scenarios. The when directive allows you to conditionally execute a task based on a specific condition. For example, you might want to install a package only on Ubuntu systems. In this example, the task will only be executed when the condition, Ansible_distribution == Ubuntu, is true. The changed_when directive allows you to override Ansible's default behavior for determining whether a task has made changes. For instance, you might want to consider a task as changed even if it doesn't modify anything on the system. In this example, the changed_when false ensures that Ansible considers the task as changed regardless of its actual impact on the system. The failed_when directive allows you to control when a task should be marked as failed based on a condition. For instance, you might want to continue the playbook execution even if a task fails. In this example, failed_when false ensures that Ansible continues with the playbook even if the task fails. You can also combine these directives for more sophisticated control. For example, you might want to execute a task only when a certain condition is met, and if the task runs, you want to consider it changed. In this example, the task is executed and considered changed only when some_condition is true. These directives provide powerful ways to control the flow and behavior of tasks within your Ansible playbooks, allowing you to create more flexible and responsive automation scripts. As we conclude this Ansible tutorial, you've laid a solid foundation in Ansible basics. In the upcoming episodes, we'll venture into advanced topics, taking your automation skills to the next level. If you're excited about mastering Ansible, hit that like button, subscribe to Techhandy, And stay tuned for more tech insights. I'll catch you in the next episode. Happy automating!